Okay, guys, you ready? On lesson 4.2.3, we're starting off with just, okay, can you fill in that chart? Either A, do you have it memorized, which I'm not really expecting that right now, or B, can you use the triangles to fill it in? Okay, so first of all, degrees, the 30 degrees, 45 degrees, 60 degrees. Do you remember the radians at least? What's 30 degrees? Pi over 6. If you don't remember it's pi over 6, what's plan B? How do we get to pi over 6? Multiply by pi over 180. Okay? 45 degrees is pi over 4. And 60 degrees? Pi over 3. All of those can be gotten to by multiplying by pi over 180. Now, you don't have to set the triangles up to fill in this chart. However, it's part of my teaching method, so guess what? I'm setting up my triangles. I've got a 45, 45, 90 triangle, and I have a 30, 60, 90 triangle. What do you guys remember about the 45, 45, 90? Okay. My legs are equal. We call them both 1. And the hypotenuse is what? Not 2. Square root of 2. Because in order to get the hypotenuse, you multiply a leg by square root of 2. What about the 30, 60, 90?
The opposite side is 1. The bottom leg is square root of 3. And the hypotenuse is 2.
Okay. So the short leg is what I'm going to call it is 1. The hypotenuse is double that, so the hypotenuse is 2. And the long leg is the short leg times the square root of 3. So we use square root of 3 for that relationship. Okay? Be able to fill those triangles in. As I said, I put the triangles on the quiz because those triangles are an important part of being able to do everything else. Okay. I'm going to refer to the triangles to fill this in. Sine of 30 or pi over 6. How do I do sine? What's my phrase? SOHCAHTOA, right? So opposite over hypotenuse, 1/2. And I'm actually going to write out SOHCAHTOA down here. Okay. Let's keep going across. Cosine of 30. Adjacent over hypotenuse, square root of 3 over 2. And tangent. Okay. Opposite over adjacent. So 1 over square root of 3. Or what's my alternative? If you rationalize it, square root of 3 over 3. Okay. 45 degrees. What's the sine of 45 degrees? 1 over square root of 2, which rationalizes to be square root of 2 over 2. What do you guys remember about sine and cosine of 45 degrees? They're the same. You don't necessarily have to. I mean, on the quiz, I will accept either one or the other. Bad way to put it, but I don't know how else to put it. However, when you're doing this in notes, it doesn't hurt to put both just so you become familiar with them. That would be my thought. Tangent. Do you remember the tangent of 45? 1, because it's opposite over adjacent, 1 over 1. Now, the bottom row. We can use the triangle, yes, because you can do 60. Sine is opposite over hypotenuse. Or, do you remember how the bottom row is related to the top row? Do you remember? Sine and cosine flip. So notice we were just coming up with, not that flip, the fact that sine of 60 is square root of 3 over 2, which is the same as cosine of 30. So what do you think about cosine of 60? Same as sine of 30, which is 1 over 2. Okay? And again, go to the triangle adjacent over hypotenuse. How's the tangent of 60 related to the tangent of 30?
It's 1 over square root.
1 over, no,
No.
square root of 3 over 1.
So yeah,
It's the reciprocal. And again, opposite over adjacent. Triangles still tell me the answer too, but I'm trying to get you to see connections, things to remember. Okay. So beginning of next week sometime, you guys are going to be ready for a quiz on that, right? Okay. As we look at the next section, we are trying to find missing pieces today. Now, honestly, the chart was a review. As you'll notice, can I use the chart in what I'm doing today? What do you notice about angle or problem A? There's a 37-degree angle. So does that fall into my 45, 45, 90 or 30, 60, 90? No. Okay, so we're using our trig functions today.
There's a 90 degree.
There is. That's all that matches up. So that doesn't count for much. Example ABC, say, given the following right triangles, find the missing sides and angles. So by the time we get done with each of these, you should be able to see 3 sides, 3 angles. Now, some of that information is given. Our job is to find any missing angles or sides. You got a question, or are you going to get me started? Okay, go for it.
For the missing angle on A, can you do 90 plus 37 and then subtract that from 180?
Yes. Because all 3 angles in a triangle always add up to be 180. So you can go with the idea of 90 plus 37 is 127. And 180 minus 127 is 53 degrees. Because this is a right triangle, what's the other option that would work to find that 53? If this one angle is 90, what do you know has to be true about the other 2 angles? They would have to add up to the other 90. And so the other way we could have done this is 90 minus 37. They're both equally correct, okay? As long as you understand why you're doing the 90 minus 37, that doesn't work for all triangles, it's good to go. Okay, we got the easy part out of the way. We got the angle. My hint is trig functions.
A squared plus B squared equals A squared.
Well, I can't use a squared plus b squared equals c squared because in order to use Pythagorean theorem, you have to have 2 of them. And again, my hint is trig functions. SOHCAHTOA. I'm going to use SOHCAHTOA here.
Well, you know that A and B are equivalent to 1. Just know are equivalent to 1, right? Because up in the top, 45, 45, 90, it's 1, 1 squared 2. It's not 45.
But this isn't a 45, 45, 90. So what connection could we make, say, between the 37 degrees, the A, and the 8? What connects those 3? 37, the A, and the 8. No.
I have a question of how to get the answer, but I don't have to be true for all of this. Like, since both of those sides equal the hypotenuse, and since one is longer than the other, couldn't you just figure that A equals 3 and B equals 5? That wouldn't work? Is that the answer?
It doesn't work.
Preston, did you have a thought when I said that what connects the 37, the A, and the 8?
I did that. But I remember doing something.
From what the morning class said, you guys did this in geometry.
sense to.
I feel like I know what you're saying, but I can't get it out.
37 degrees. I picked 37 degrees to use. We could pick either angle. 37 degrees, A and 8. What trig function connects those? No. Not if I'm saying A and 8.
Well, that's opposite and hypotenuse. So these.
Sine. So we can say the sine of 37 degrees is equal to A over 8. Let me give you the visual. The sine of 37 degrees is equal to A over 8. Now, by the way, I'm not saying this is the only way to find A. That's not what I'm saying at all. This is an option. Okay? Can we solve this equation? Because we just wrote an equation. Can we solve that for A? If it's A divided by 8, what do we need to do? Multiply by 8. So then A is going to be equal to 8 times the sine of 37 degrees. And what do you need to finish this problem off? Or to finish A off? Calculator. So do please grab your calculators today and practice with me. It's not that it's incredibly difficult. That's not what I'm saying at all, but we don't want to make careless mistakes. Notice when I did A times the sine of 37, first of all, you can't do 37 times 8. This is not 37 times 8. It is 8 times the sine of 37. So if you want to put that 8 out back, it has to be after the parenthesis. And 37 is degrees. I purposely don't tell you guys that. But you do have to be in degrees to get my matching answer. And I don't tell you guys because I want you guys to learn to think which degree or which mode do I have to be in. So, did you guys finally get the right answer though? If I go 2 decimal places, A is approximately 4.81. Okay. We found the missing angle. We found A. Now we have to find B. Thoughts on how I can find B? Okay, so Pythagorean theorem. Technically, yes. However, one, I want us practicing our trig functions, so I don't want you using it for that purpose. And two, you have to be very careful because if you try and use the rounded decimal, it could throw you off. But here's what ultimately it comes down to. I want us practicing the trig functions today. That is the goal of this lesson, so I don't want you using Pythagorean theorem. Technically, if you use that full long unrounded decimal, will you get the correct answer using Pythagorean theorem? Yes. So do you hear what I'm saying? I'm not saying you can't use it, but
yeah, I'm just trying to.
This is what I'm trying to get you guys to do. Yeah. Okay, so if I toss Pythagorean theorem out, what are our other options? Cosine of 37? Okay. Cosine of 37. Cosine is adjacent over hypotenuse. Could that work? Yes. We could say the cosine of 37 degrees is equal to B over 8. Is that the only way to finish this problem? No. Now, as much as I say, okay, don't use this A value. Don't use Pythagorean theorem, and don't use any trig function that's going to use this decimal. Okay, because this is a rounded decimal, right? On the flip side, could you do something with 53 degrees if you wanted to? You can, because the only thing I hesitate with 53, could you have made a subtraction error? You could have. But other than that, it's a whole number. So I'm not against you guys using the 53 degrees. So you could have also done like the sine of 53 degrees is B over 8. Doesn't matter. If you do the sine of 53 is B over 8 or the cosine of 37 is B over 8. You're going to get the same answer both ways. So how do I solve for B? Yeah. If it's B divided by 8, we're going to multiply by 8. So B is 8 times the cosine of 37 degrees. My calculator is going to do the work. And does your answer match mine? Should be in the right mode now. So Approximately 6.39. Good news is on this homework, should be once you get your calculating degrees, you don't have to flip back and forth. Last night's homework had you specifically flipping back and forth on purpose. Okay, tonight, not so much. Okay, questions? Let's try B. Where would you guys like to start on B? Okay, Chandler wants the easy angle out of the way.
90 minus 57 is 33.
Okay, he's going for the route of 90 minus 57 is 33. The other option would be 57 plus 90 is 147. And 180 minus 147 is 33. Okay, we got the easy answer out of the way. Next. I don't care if we do X or Y first. We've got to use that 13 with it. Technically, we can use 57 degrees or 33 degrees. My preference would be the 57 just because I know I didn't make any subtracting errors there. That was given. But you could use either or. Give me a connection that works. Okay, sine of 57 equals what? Okay, I can go for that. Does that work for you guys? Sine of 57 degrees equals 13 over x, because opposite over hypotenuse. Unfortunately, because we don't know the hypotenuse in this problem, it's going to be a teensy bit more work to get to our answer, because we have x in the denominator here, right? So first of all, if it's 13 divided by x, how do I move the x? Multiply. So I'm going to multiply the x to the other side. So I'm going to say x times the sine of 57 degrees is equal to 13. And then how do I get x by itself? Divide by sine of 57. So x is 13 divided by the sine of 57 degrees. When you don't know the hypotenuse, there is one other extra step in there somewhere.
So it's the sine of 57 times 13.
No, that's not what I have written on my paper, at least. Make sure you know how to put this in your calculator. Again, not that it's a crazy difficult deal, but does your answer match my answer? Should be approximately 15.5. What are options for finding y?
Use the sine of 33.
I would rather not.
So the cosine of 57. Give you
I would rather not.
tangent of 57.
I could go for tangent of 57.
When you said you'd rather not, do those not work? Or they could, but they won't work.
Okay. If you use sine or cosine, those both involve hypotenuse. My hypotenuse is around the decimal. I would rather use the given 13. Okay. You definitely want to use the whole number, not a rounded number. Again, I would just go with whatever you do, use that given side they give you. Don't use a side you have just found that you then had to round that decimal. Does that make sense? If it came out to be a nice, neat whole number side, I wouldn't be against it. But because it comes out to be a decimal, it's not worth the hassle. Does that make sense? Okay. So, I forget which way Cole said. He said tangent of 57. And technically, you could do tangent of 57 or tangent of 33 here, couldn't you? If you want to get technical. I'd prefer the 57, though. Tangent of 57 is Opposite over adjacent, which is 13 over y. Multiply the y out of the denominator. So y times the tangent equals 13 to get y by itself. Divide. And so y is 13 divided by tangent 57, which is 8.44. And I'm not going to say you couldn't have used sine or cosine and gotten the right answer. Just whole numbers are always much better. But pretty much the same reason I'm not encouraging you to go Pythagorean theorem. No. Besides the fact we're learning the trig functions today. I mean, we're learning the basics here. These will be used within bigger problems later on is what it's coming down to. So, okay, see. You guys tell me. Okay, to get that angle, you can do the shortcut of 90 minus 21, which is 69 degrees. Okay, we got the easy part out of the way. Next. Okay, cosine of 21 degrees. I can go with that. Cosine of 21 degrees is adjacent over hypotenuse. 14.2 over n. If it's 14.2 divided by n, I'm going to multiply. N times cosine of 21 degrees equals 14.2. If it's n times cosine, divide. So n is 14.2 divided by cosine of 21 degrees. My calculator says, actually, your calculator says, $15.21. And lastly, how do you guys want to find m? I'm going to veto you for the same reason I did last time.
You do sine of 69. But since I guess it's not rounded,
Exactly.
I was just an angle.
I get it, they're both decimals, but I want you to use something that uses this 14.2. Okay? Don't use the n, don't use the hypotenuse. So, which trig function does not use hypotenuse? Tangent. Okay? And so, tangent of, which angle do you guys want to use? We stick with tangent of 21 degrees. What is the tangent of 21? M over 14.2. If it's m divided by 14.2, multiply. So m equals 14.2 times tangent of 21 degrees. And is some decimal? 5.45. Now, no one brought up in this class. Technically, we have 3 other trig functions we didn't even talk about.
Yeah, I thought about that.
Technically, we have secant, cosecant, and cotangent, yes? However, do we have nice, easy buttons on the calculator for those? No. You'd have to type it in, use it as a reciprocal. What's easier to use? Sine, cosine, tangent. I'm not saying you couldn't use those functions, but I'm not going to encourage it. Same reason, I'm not saying you couldn't use a decimal side to find another side, but I'm not going to encourage it. Okay, one last problem. we will definitely be seeing word problems such as these as we go through this chapter.
Is this the last part in this section?
Yes, we will finally be done with lesson 4.2 today.
It's been pretty easy.
Yeah, it's not too bad, but if I would have done it all, tried to do it all as one big lesson, I wouldn't have liked it. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65 degrees. Find the height h of the building.
Since it's 90 degrees, do 90 minus 65.
To find the height,
But never mind. I was thinking of the triangle. You gotta find all 3 degrees.
all I need, so yes, we want to think triangle here, which means what am I going to encourage you to do? Draw a picture, right? You realize that we're going to end up with a triangle in the end. That's the whole point of this, you know. We're going to use our trig functions. It's going to be a triangle. Even more specifically, it's going to be a right triangle. So, we have a building. There's my fancy building. And we have a point. So there's my person at this point. And this person is 340 feet away from the base of the Peachtree Center Plaza. What else do we know?
That's the angle of the top of 65 degrees.
Okay, so do you guys understand angle of elevation? Angle of elevation is as I look up, I'm looking up. If I'm looking up at the top of the building, it's a 65 degree angle from the horizontal ground, right? So that means as I look up, this angle here is 65 degrees. What am I being asked to find? The height of the building. And of course you realize the building and ground make a right angle. So there is my lovely picture. Your picture could be a basic triangle. It does not have to have a person in a building. It's a triangle. That's what you need to draw. Okay? I don't have to have all the pieces. All I need is h. What's the connection that will allow me to find h with the information I'm given? Tangent? Because here's the angle I know. Tangent is opposite over adjacent. So, tangent of 65 degrees is equal to h over 340. If it's h divided by 340, multiply by 340. So h equals 340 times the tangent of 65 degrees. This is a calculator problem to finish it up. Nice thing about word problems is it's not likely that they're going to say, oh, well, that's pi over 3 degrees or something, you know, or pi over 3 radians as the angle. They're going to give it to you in degrees, right, if it's a word problem. What'd you guys get? Okay, 729 and 1300 feet is the answer you end up. And 61, 265. Sometimes you're finding one piece, sometimes you're finding all missing pieces. It just depends on the problem. And, okay, it's not a lot, but it's 6 minutes. You can get a little bit done.